Hi guys. So my name is Vinay Jain and today we're going to talk about breadth first search algorithm. So what is a breadth first search algorithm? So let's assume we have a tree like this, which is structured like this. The breadth first search, the breadth first search traversal of this tree would look somewhat like this. First, the node 1 is encountered, then 2, 3, then 4, 5. So this is the breadth first search traversal. So that breadth first search traversal is essentially whatever level you are at currently. So what are the nodes at that level in left to right order? You can do right to left order, but left to right is the most conventional method. Then when you have finished traversing those nodes at this level, go to the next level, and what are the nodes there? 2 and 3 in left to right order. Then next level, what are the nodes in which order are they? 4 and 5. So this is your breadth first search traversal. So you encounter 1 first, then 2 and 3 first, then 4 and 5. So how can you code this? How do you go about it? So let's understand this algorithm via an example. So let's assume we have a tree which looks somewhat like this. We have a node 1, node 2, node 3, node 4, node 5, node 6, node 7. Let's say we have 10 here, 11, and then 12, 13. So what would the breadth first search traversal look like this? Look for this example, and let's say we are trying to find a node which is at the target node whose value is 13. So how do we find this? So this is the root of the tree. So we start from the root of the tree. We use a queue. Queue is essentially a data structure which works based on first in. Whatever comes in first is the first one to go out. So let's say we have a queue here. This is just a queue depiction for queue, and this is the front of the queue, and this is the back of the queue. And let's say we have another variable, let's name it pop node. So this variable is essentially responsible to hold the nodes popped from the queue. So essentially this would be empty in the beginning. So our first step for this algorithm is to push the root of the tree into the queue. So what we do is we push the root node 1 into the queue. Once we have done that, then we start our traversal, which is basically checking as long as the queue is not empty, as long as there is something in the queue, we pop the frontmost part of the queue. So what is the frontmost part of the queue right now? That is node 1, right? So we pop that and we put it in a variable, store it in a variable, let's say pop node 1. Once we have done this, we check if is this our target, is this what we want to find? No, then we proceed ahead to check if it has any left or right child nodes. If it has, first, does it have a left child node? Yes, it does. So push it onto the queue, add it to the queue. And so this is essentially one has a left child 2 and a right child 3. So we push the left child onto the queue, and then we check for the right child. Does the right child exist? If it does, then push that as well onto the queue. So once we have done this, our first iteration of the algorithm is completed. Then we keep a track of a visited set as well. You can do that for your convenience to make sure you do not work with the same node again and again. So visited set is essentially the set of nodes that you have already visited. So since you have already worked with node 1, so you add this to the visited set. Now you again iterate, you check whether the queue is empty or not. It is not. What is the topmost part of the queue? Node 2. So you pop it and put it here in pop node. Once that is done, you check whether 2 is the target variable, a target that you have to find or not. No, it is not. So you check whether it has left or right nodes or not, child nodes. Yes, it does. So you just add those child nodes to the queue. 4 is the left child added to the queue. 5 is the right child added to the queue. Now since we have added the child nodes, we add the node 2 to the visited set. Next, In next iteration, we again check the top of the queue. It's not empty. So we again pop it, whatever is at the top of the queue, and put it in pop node. Is this the value that we're looking for? No. So we check for its left and right child nodes. So for the left node is 6. Sorry, my bad. And the right child node of this pop node is 7. So we add these to the queue, and now we're finished processing. So we add this to the visited set. What is the top of the queue now? 4. So we pop this and put it in pop node. Is this the value that we're looking for? No. So we check its left and right child nodes. Do they exist? Yes. For the node 4, we do not have any left child node, so we do not add anything to the queue. Similarly, for the right child, 4 does not have any right child. Both are null, right? Since both are null, that is why we do not add anything to the queue. We just add this to our visited set, and then we proceeded ahead. So in our next case, this node is popped, node 5, which is at the top of the queue, and pop node now refers to node 5. Does node 5 any child nodes? No, it doesn't. So we just add it to the visited set and move on. What is the top of the queue now? 6. Does it have any child nodes? No. Before that, 6, and this is the reference that we're working with. This is the node that we're currently working with. Is this the value that we're looking for? No. Then does this have any children nodes? No. So we don't add anything to the queue. We just update our visited set. So the next node, the top of the queue is 7 node. So we pop that and push it onto pop node. So now the pop node is referencing to the node 7. Does this node have any child nodes? Yes, it does. So first of all, is this the value that we're looking for? No, right? So we check for its children nodes. Do they exist? Does left child exist of this node, node 7? Yes, it does. So we push it onto the queue. I'm just writing this here. Does the right child of the queue, does the right child of node 7 exist? Yes, it does. So we push that as well onto the queue. Now, once we have done that, we add this to our visited set to keep track of what all nodes we have visited. Now, what is the top of the queue? The front part is, this is node 10, right? So we pop that and push it onto pop node. Now pop node refers to node 10. Is this the value that we're looking for? No. So what about its children nodes? Do they exist? No. Both are null, right? So we don't add anything to the queue. We just add this node to our visited set and then move on. What is at the top of the queue now? Node 11. So we pop that and push it here, and now the pop node refers to node 11. Does this node 11 have any children nodes? First of all, does this node have any, like, is this the node that we're looking for? No, right? We're looking for node with value 13. So we check for its children nodes 12 and 13. So left child is pushed onto the queue, and now the right child is also pushed onto the queue. Once this is done, then node 12 is popped, since that is at the top of the queue now. Is this the value that we're looking for? No, right? So we move on and check for its children nodes. Again, there are no children nodes, so we don't add anything to the queue. And then we check for, we add this to our visited set. Sorry, I forgot to add node 11. We add that, and in the next iteration, we add node 12. Once that is done, we pop the node 13 in the next iteration, assign it here. Does the node 13, is that the value that we're looking for? Yes, that is the value that we're looking for. So we return this value. So essentially, using this traversal, you have figured out level by level that node 13 exists in the tree depicted here. Notice that every time you pushed, you were working with a single node, and when you pushed this left hand child onto the queue, you were essentially doing breadth first traversal, because you were traversing over every node in the level and then moving on to the next level. The node 1 was processed first, then node 2, 3, as you can see in the queue, then node 4, 5, 6, 7 in that order, and then node 10, 11, 12, 13. So this is essentially what is breadth first search traversal. So the algorithm for this is like as I've written it here. So what you're supposed to do is create an empty queue and visited set. Once you have done that, push root of tree in queue. So that is from where you have to begin. And then as long as the queue is not empty, as long as there is a node in the queue to work with. So what you do is you use a variable pop node and you pop the front of the queue. Once you have popped the node, you check whether that pop node's value is equal to the target that you're looking for or not. If it is, if that means you've found your node that you're looking for in the tree, and then you return true, basically saying that the node exists in the tree. If that is not the node that you're looking for, you move forward and you add the children of the pop node to the queue. You check whether the left child exists or not. If it does, you push it to the queue. If the right child exists or not, you push it to the queue. This is essentially ensuring, this is the part which is essentially ensuring breadth first traversal, or should I say level order traversal. So level by level you're encountering the nodes, and then that's how you're working with it. And then you update your visited set with the pop node, basically saying that you've encountered this node. You keep on working as long as you don't have anything in the queue, and once you have nothing in the queue is empty, right? So that is essentially signifies that you have processed the complete binary tree. You have processed the tree, or you have found your node. So if this situation is encountered any time in between, that means you found your node. If you have iterated completely and you still not found your node, if the queue is still empty now and you have not found your node, that means the node doesn't exist in the queue. This condition here was never encountered. That means the node doesn't exist in the tree. So therefore you return false, signifying that the node doesn't exist in the tree. I hope you like watching this video. I hope this helped clear your concepts. I'll attach the link for the breadth first search algorithm in the description below for my GitHub repository. I hope you guys enjoyed this video. Keep watching, keep coding.